Hello, my name is Porter Glines. I'm a master's student from Idaho State University, and I'll be presenting our paper, Software Design Patterns of Computational Creativity, a Systematic Mapping Study. I'd like to thank and credit my co-authors, Isaac Griffith and Paul Bodley. So with this paper, our goal was to try and figure out the state of the art of design patterns in computational creative systems. So with that in mind, software design patterns. They're reusable solutions to commonly occurring problems in software development. Shown here is the popular model view controller design pattern, popular in web applications and mobile apps, as well as the more traditional strategy design pattern, which is one of they're called Gang of Four design patterns, and they're often taught in college CS programs. So with software design patterns, the idea is that if it's made known that a design pattern is being used, a programmer or system architect can have a pretty good idea about how the code base is laid out, or how classes in object-oriented systems will interact with each other. So software design patterns are most relevant to the field of software engineering. So why discuss software design patterns for CC? And we think that as CC systems become more complex and collaboration on these systems becomes more common, introducing some software engineering principles through design patterns has the potential to help CC practitioners create better CC systems, we think at least. And software design patterns they're used in practice with the goal of improving reusability, understandability, and maintainability, among other things. And reusability and understandability could help directly facilitate the collaboration on these CC systems. So with that in mind, we set out to investigate if CC literature mentions design patterns, and if there are CC-specific design patterns. Our inspiration for this investigation comes from Dan Ventura's work with his paper, How to Build a CC System, in which the components to an abstract CC system are described. And we thought, hey, maybe there's common ways or patterns used to construct these common components. For instance, is there a common pattern to constructing the knowledge base or genotypic evaluator, or maybe common patterns to how these components interact? And we set out to investigate this idea by conducting a systematic mapping study. But really, this idea was the spark for our investigation. A systematic mapping study is a kind of literature review that came out of the field of empirical software engineering. And we conduct the SMS as described by Peterson et al. And the process is visualized here. But the process includes things such as carefully defining research questions, search procedures, inclusion-exclusion criteria for filtering out or screening papers, as well as other steps, and the details of which, including the research questions, can be found in the paper. But the real important steps of the SMS process is the search strategy and how the primary studies are selected or filtered out. The search was performed over ICCC proceedings from 2010 to 2020. including the 2011 conference that was also held in Mexico. And proceedings were manually searched using key terms, and then inclusion-exclusion criteria started to filter out papers. And the filtering process would proceed in steps. So we would first look at the titles and abstracts. If papers made it through, we would then look at the introductions and conclusions, and then if they make it through that, full readings would be warranted. And once a base set of primary studies is identified, the search would happen again, and it would be performed on papers that reference any of the primary studies. This is called a forward snowballing search, and we would use Google Scholar's citing feature to search for any papers that reference the primary studies. So as far as our results, out of the 544 papers searched, only 7 primary studies were identified, and most of which come from ICCC, but the snowballing search did yield a paper from a AAAI affiliated conference on artificial intelligence and interactive digital entertainment. 14 unique design patterns were mentioned in these papers, including one more traditional Gang of Four design pattern, the strategy design pattern, and most of the design patterns come from Compton and Mateus's paper titled Casual Creators, all of which we sort of classify these design patterns as user interaction design patterns. And these would include patterns such as instant feedback, mutant shopping, no blank canvas patterns, etc. And this graph on the right shows how the papers were distributed regarding the year they were published. And while it's interesting to note that a majority of the primary studies were published in 2020, there's so little data that we can't state if it's a trend or not. The 14 design patterns mentioned in the studies are included here. Like I said, most of which were user interaction design patterns. Actually, 12 of the patterns are user interaction design patterns, and they don't necessarily inform about the code base, but rather they inform about the interaction with the user. So we make that distinction in our paper. On the right here is showcasing 2 such CC systems which use the user interaction design pattern mutant shopping, in which users are shown a number of generated options, and they can pick parent artifacts to generate more artifacts in a co-creative process. And PickBreeder here is an exploratory image generator, and then Germinate is a rhetorical game generator, both of which are using the mutant shopping design pattern. So from our results, we found that UI design patterns are much more often mentioned, which makes sense as they are particularly relevant to co-creative systems. Overall, though, design patterns are not often mentioned in CC literature. However, they still might be used in CC systems, just not mentioned in the papers. But to investigate that, we will need to investigate the systems themselves, the code bases themselves, and try and identify patterns there. And we leave that as future work. This future work might also lead to discovering new design patterns or design patterns specific to CC. For example, patterns specific to the components of the abstract CC system mentioned in Ventura's paper. And we see that as exciting future work. So overall, this paper intends to open a discussion on if CC system builders should use design patterns and or mention design patterns in their paper, in their papers if they're already using them. And we think the potential benefits of more reusable, more understandable, and more maintainable systems warrants consideration of the CC community. And I thank you for watching.